Hey guys, I just wanted to talk about some special exponent rules today. So I would love for you to get out your class notebook and write these down with me. So you might need to pause and go get that. But it's really, really short, so please do actually write them down. So special exponent rules have to do with the numbers 1 and the number 0. Let's start with number 1. Okay, the number 1 can be found in two ways in an exponent, right? Because there's two parts to an exponent. We have the base and the exponent itself. So let's start with what happens when this is the base. So 1 is the base. So when 1 is the base, that means that, again, you're going to multiply the number by however many times the exponent is there. So if I have 1 to the third power, that's equal to 1 times 1 times 1, 3 times. Well, 1 times 1 times 1 is just 1. Okay. If I had 1 to the seventh power, I would do it 7 times. 1, 2, 3, 4, 5, 6, 7. And guess what? 1 times 1 times 1 times 1 times 1 times 1 times 1 is 1. But then I get to times when it's like 1 to the 103rd power. I did not want to write that out that many times. And of course, you now know how to use a calculator, but I think that you are kind of starting to see that there's a pattern here. The only number you multiply is by 1, and 1 is very special because no matter how many times you multiply it by itself, it stays 1, right? 1 times 1 is still 1. Times it by 1 again, it stays 1. Times it by 1 again, it stays 1. So this is just going to be equal to 1. So the punchline here is that 1 to any power or exponent equals 1. Now, the mathematical way of writing that is, let's write it in color, shall we? Notation. 1 to any power. Well, when we don't have when we have an unknown, we can use a variable to represent that. 1 to the x power equals 1. No matter what x is, you're always going to get 1. So we can put in anything we want here, and we're going to get the number 1 back out. Okay, so very, very simple. So when the 1 is the base, it's multiplying 1 times itself a whole bunch of times. And no matter how many times you do that, you will always get 1. Now, the other option is that 1 is the exponent. Okay, and if 1 is the exponent, let's see what that looks like. If I have 3 to the first power, well, that means I'm multiplying that number by itself once. Well, that's just 3. What about if I flip that one? 7 to the first power. Again, I need a 2 to do it twice, so literally it's just 7 once. That's just 7. Okay, and here it's even easy. If I flip that one, 103 to the first power equals, and then same thing. It's just 103 by itself the one time. That's still 103. And the same works for a negative. If I put like a -2 in parentheses, and remember the 1 goes on the outside, then that's just the number -2 by itself one time. So it's just -2. So notice every time the number is just itself. So the 3 to the first power is just 3. 7 to the first power is just 7. 103 to the first power is just 103, and so on. So the idea here is that any number to the power of 1 or exponent of 1 stays itself. okay? And the way we can write that using the notation is, let's call it b for base to the first power is equal to b. It stays the same. So whatever this b is, I know it kind of looks like a 6, I'm sorry. If you raise it to the power of 1, well, it just stays the same, okay? And something else to note is that just like every variable has a coefficient of 1, whether or not you can see it or not, every number has an exponent of 1, whether or not you can see it. So let's give that a little, let's write that down. Every number has, and variable, has an exponent if you don't see it, and I put C in parentheses, you know, we don't see it, but we know it's there, then the exponent is 1. Okay, so if you see, just like the number 4, it actually does have that exponent of 1. You just didn't see it before. So you can add that in if you want. You don't have to, but that will help you with some math that we do this week. Okay, so that's the deal with ones. Okay, so hopefully that was pretty easy. Well, where's the other number? The other number that makes, gives us some special rules is the number 0. And just like 1, we can have 2 options for this. The first one is that 0 is the base. Okay, this is probably going to be very similar to what we have above. But if 0 is the base, let's see what happens. If we have 0 to the third power, then we would have 0 times 0 times 0, 3 times. Well, what do you know? That's 0. What about 0 to the 7th power? Well, that's 1, 2, 3, 4, 5, 6, 7. And I'm going to go back and put the parentheses in. It's a little bit easier for me to do it that way. But 0 times 0 times 0 times 0 times 0, don't believe me, check it on your calculator, that's 0. Okay? And flash forward, just like we did above, if I did 0 to 103rd power, I'd have to write 0 times itself 103 times. I don't really want to do that. So if you can kind of see here, we're kind of forming a similar pattern like we did above. No matter how many times I multiply 0 times itself, it's going to stay, you guessed it, 0. Okay? 0 times 0 is 0. Times it by 0 again, it stays 0. Times it by 0 again, it stays 0. So just like 1 to any power stays 1, 0 to any power stays 0. So we would say 0 to any power slash exponent, whatever, doesn't matter, equals 0. Okay, and so using our notation, just like we did above, 0 to any power, doesn't matter what it is going to stay equal to 0. Now there is one exception to this rule. One exception to this rule. And that is 0 to the 0 power. And that we would say is undefined. Just like you can't divide anything by 0, you're going to say this is undefined. Okay, so it's just a weird rule, but remember it. And the reason is that it's contradicting, and you'll see why it's contradicting in a second. Okay, so 0 to any power stays 0. Okay, now let's look at the flip side of that. What happens when 0 is the exponent? Okay, so now the power is 0, or the exponent is 0. So if we had 3 to the 0 power, well, here's the thing. Before I had 3 to the 1, so I was able to write just 3 one time, but now I'm not allowed to write it at all. That's very, very confusing. And the instinct would be that the answer is 0, but it's not. It's actually the number 1. Okay? Why is it the number 1? Well, if we make a table here, and this is our exponent, and this is our value, okay? So let's do 3 to the 0, 3 to the first, 3 to the second, 3 cubed, 3 to the fourth, 3 to the fifth, okay? So we have this. We learned above 3 to the first power, that's 3. 3 squared, that's 3 times 3, that's 9. 3 cubed, that's 3 times 3 times 3, that's 27. 3 to the fourth is 81, and then I don't know what 3 off the top, 3 to the fifth is off the top of my head. It's 243. Okay, so that leaves us the question to what in the world is 3 to the 0 power? Well, this has to follow a pattern. And the pattern is, as I move from left to right, I am timesing by 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243, and so on and so forth. Well, this works when we also go backwards. But when we go backwards, we have to do the opposite of times 3, and that's divide by 3. So 243 divided by 3 is 81. 81 divided by 3 is 27. 27 divided by 3 is 9. And 9 divided by 3 is 3. Well, that leads us to 3 divided by 3. Well, 3 divided by 3 is what? It's 1. Dun, 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 dun. It's 1. And that works because if I do 1 times 3, just like the red pattern I have, I'll get 3. If I had 0, like I wanted to do, 0 times 3 is just 0. It wouldn't work. It has to be 1. And this works always. If you do 7 to the 0 power, that's also 1. If I do 103 to the 0 power, that's also 1. You don't believe me? Check on the calculator. 103 raised to the 0 power is 1. Okay, I know that this was a quick explanation. If you would like more info on it, of course, let me know and I can send you some videos. But it has to be 1 to make this mathematical pattern work. To go backwards, I divide by 3 and that gets me the 1. And then if I go backwards again, you'll see later that that continues in another pattern that I keep dividing by 3. Okay, so the punchline here is that any number to the power of 0 equals 1. Okay, any number to the power of 0 equals 1. So the notation for that is b to the 0 power is equal to 1. Always. No matter what b is. B could be 3, 7, negative 27, as long as it's raised to the 0 power. Negative 27 to the 0 power is going to equal 1. Okay, except 0 to the 0 power, which you write undefined. Okay, if you ever see that, you go, oops, because here's the rule. Any number to the 0 is 1, 0 to the any number is 0. Well, this can't equal 0 and 1 at the same time, so we say undefined. So that's the only exception to this whole rule, okay? So hopefully that helps you. I know the video is a little long, but as far as notes go, they're not that bad. And then you'll see that the worksheet for today should be a breeze. If you have any questions, let me know, and good luck.